Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afif bin Zuhairi. Okay, for the assignment part 2, we have to solve the this question. Okay, for the question A, you want to sketch the free body diagram. So this is our free body diagram. Okay. I proceed to the next question. The next question, you want to calculate speed of the object just before it leave the surface at B. It means you want to know about our project. So for our project, we use the ball. For the football match, the 500 gram. And then for this question, before we want to solve this question, we use this equation. For this equation, just substitute the mass is 0.5. We get from the 500 gram, and then the mass also 0.5, and gravity just substitute it 9.81, and the height 2.5. 2.5 we get from the 3.5 minus 1. Okay, so just calculate it. 1/2 times 0.5, we get the 0.25, and then 0.5 times 0.5 times 9.81 times 2.5, we get the 12.263. Okay, at the end we get the answer for the speed of the object. We get the 7.004 meter per second from this all. Thank you.
My name is Ahmad Isudin Abdul Razak. So I will continue with our discussion for this question. Before this, my friend just discussed about question 1 to A is for the sketch of the FBD, B is to calculate the speed. So the question C is to calculate the distance from the wall of the ramp at B to where the object strike the ground. So first of all, this question we have to calculate two components, that is X component and Y component. So to calculate the X component is we have to use the equation is XC equal to XB plus VBX plus TB, this equation. So from this equation we can get that D is equal to 7.004 TB. That is for the X component. After that is we have to calculate the Y component. We have to use the equation of YC equal to YB plus VB multiplied with TB and minus 1/2 GTB square. So we calculate this. YC is equal to 1, YB is 0, plus VBTB is 0, and this equation is 1/2 multiplied with 9.81 and multiplied with TB square. So we can get from, after we calculate this, we can get is TB equal to 0.455 seconds. We didn't finish yet this question because we didn't find the D. So the D is, we can substitute TB into D. So D is equal to 7.004. TB is 0.455 multiplied. So we can get 3.2 meters. That is the distance for this question, that from the wall and of the ramp at B for this the wall. That's all. Thank you. Hi. So let's continue with the next question is D. So this question is we want to compute the speed at which the object hits the ground. So for this, to solve this question, we have to use this equation, that is TA plus summation U1 to 3 equal to TC. So from that we can get that TA equal to 1 over 2 MVA square plus summation U is VC square equal to 1 over 2 MVC square. So we put the value to this equation is 1 over 2 times with 0.5 times 0 plus MGH for the VC square equal to 1 over 2 0.5 multiplied with VC square. So from this we can get 0. So only left is MGH equal to 1 over 2 multiply 0.5. So we continue with is M 0.5 multiplied with 9.81 multiplied with 3.5. So we can cut off the 0.5 because it has same value. So we calculate and we can get is VC square equal to 68.67. So the square root we transfer to the side become the square we transfer to the side becomes square root. So VC equal to square root 68.67. So we can get the answer is 8.287 meter per second. So that is the speed which the object hits the ground equal to VC. That's all. Thank you.
Hi, my name is Farsi Malvin Mamano. So I will continue with the question 2A. The question asks to calculate the velocity of the object just after it rebounds from the ground. So first, step 1, we use this equation, that is negative VCY squared equal to V1Y squared plus 2AC times SCY minus S1Y, and then we substitute the value with V1Y equal to 0. 2 AC is negative 9.81 and SCY minus S1Y is 0 minus 1. So we calculate this and we get negative 4.4294 meter per second. That is the value of VCY. So VCY is 4.4294 meter per second pointing downward. So that is because the value is negative. And then we continue with step 2. We use the exponent equation. So the equation is E equal to VG2 minus VCY2 divide VCY minus VG, and then we substitute the value. The E is equal to 0.7, VG2 is 0, VCY is what we want to find, and then VCY minus VG, we substitute negative 4.429 minus 0. So we move this one here and we get 3.1003 equal to negative VCY2. So finally we get the answer VCY2 is 3.1003 meter per second. So the velocity of the object just after it rebound from the ground, we get the answer is 3.1003 meter per second. Okay, next we continue to question 2B. So the question asks to compute the maximum height to which the object rises after the first bounce. That is mean the object, okay, and then it goes down and it bounces like this. So we want to find this, the height of the first bounce. Okay, so we use this equation, m times v1x equal to m times vax, and we get vax equal to 7.004 meter per second. And then we use, this is the what we call the equation. So the equation VA squared equal to 7.004I plus 3.1003J meter per second. So, and then we use this equation to get the answer. So the equation is V2y squared equal to VAY squared plus 2AS times S2y minus SAY, and we substitute the value. VAY here we get from here, VAY 3.1003 squared plus 2AS, so 2 times negative 8.91, and S2y equal to H minus SAY equal to 0. And then we calculate this, 2 times negative 9.81, we get negative 19.62 times H. And then this one, 3.1003 squared, we get 9.612. So 9.612 minus 19.62H. And then we move this one, negative 19.62H to this side, and then we divide 9.612 divide with this one, 19.62, and we get the H. The H that we get is 0.5 meter. So the height of the first bound here we get 0.5 meter. The height of the ball that rise after the first bound, 0.5 meter. So that's all from our group, and thank you.